If an industrial robot is made weak enough to safely bump into a human without causing harm, it becomes completely incapable of lifting heavy payloads or doing any real work. That is the fundamental paradox of safe physical AI. You cannot avoid the problem by making robots so weak that they only gently bump into people, as such robots would also be incapable of performing useful tasks. The stakes here are literally massive. For decades, we've been forced to choose: protect human lives or scale industrial productivity. We've hit a wall where traditional safety measures like locking machines in massive steel cages are actively crippling the true potential of physical AI on the factory floor. So how do we make massive physical AI universally safe around us without sacrificing its brute power? Well, the answer isn't a stronger physical cage, and it definitely isn't a faster mechanical brake. It requires a fundamental shift in machine intelligence itself.
Think about the old paradigm. It relied entirely on simple mechanical limitations and reactive stops, basically pulling the plug the second something got too close. But the new paradigm? It demands advanced, real-time spatial logic. We are actively taking the highly sophisticated autonomous vehicle tech, the exact stuff that keeps cars from crashing on highways at 70 miles an hour, and porting it straight into our factories to predict and avoid collisions before they ever happen.
Section 1. Real-time spatial logic. NVIDIA Halos for robotics isn't just a software upgrade. It is the industry's first full-stack, comprehensive safety system explicitly designed from the ground up for physical AI. The Halos architecture completely unifies what used to be a totally fragmented world of robot safety. Instead of developers cobbling together a functional safety net from scratch, you get a unified three-pillar stack. First, you've got the hardware layer, anchored by the IGX Thor platform and the Holoscan sensor bridge, which perfectly syncs data from multiple cameras and radar feeds in literally microseconds. Next, the software layer, running Holos OS and Core to process that massive influx of spatial data. And finally, the ecosystem layer, which integrates partners like Fort Robotics. This specific setup is exactly what allows developers to scale humanoids and autonomous mobile robots rapidly, without building bespoke, untested safety architectures for every single new machine. And this entire framework is grounded in reality by the NVIDIA Halos AI Systems Inspection Lab. This is the very first ANSI National Accreditation Board accredited lab designed specifically for physical AI. It brings functional safety, rigorous cybersecurity protocols, and emerging AI regulations all under one roof, getting these complex integrations fully certified and legally ready for real-world deployment. Section 2. The Hardware Foundation. Enter the Advantech MIC735. This is the exact physical edge AI system making this real-time spatial logic a reality on the factory floor. 2070 FP4 teraflops. That is the sheer, uncompromised power of the NVIDIA IGX Thor platform running inside the MIC735. To put that into perspective, paired with 14 ARM CPU cores and 128 gigabytes of memory pushing 273 gigabytes per second of bandwidth, you get the massive computing overhead required to simultaneously run demanding real-time robotics workloads like navigation and manipulation alongside non-stop microsecond-level safety monitoring. And it pulls this off in the harshest mission-critical environments on Earth. The MIC735 guarantees deterministic AI performance, meaning it executes safety commands with absolute predictable timing, even in extreme temperatures from -30 all the way to positive 60 degrees Celsius. Add in high-speed 5G and Ethernet connectivity for synchronized, high-bandwidth sensor communication and a guaranteed 10-year lifecycle to match heavy equipment timelines, and you've got a true industrial powerhouse. Section 3. The Full-Stack Safety Solution. This is where that raw compute power officially pairs up with unbreakable physical control. The crucial point is right here. Safety is no longer a bolt-on accessory. Advantech partnered with Fort Robotics to embed the Nano Safety Controller Pro directly into the Edge inference system. This is an embedded, industrially rigorous SIL-3 certified receiver, meaning it meets one of the highest possible international standards for hazard reduction. It guarantees that external safety commands are securely executed by the machine's internal architecture in real time without ever sacrificing AI performance. Let's track exactly how this flows in a real-world scenario. Step 1. An anomaly, say a human worker walks into a blind spot, is detected on the work site via the NVIDIA Halos outside-in blueprint cameras, which physically extend the robot's perception. Step 2. That input is securely routed through the Fort endpoint controller. Step 3. The action is instantly executed by the embedded Nano Safety Controller Pro, immediately stopping or redirecting the machine. This proves how a massive, multi-ton robot can dynamically adapt to human proximity in milliseconds, completely eliminating the need for restrictive physical cages. So, what happens to global industry when safety is no longer a physical steel barrier, but the foundational code of every single machine? With hardware bottlenecks finally shattered by platforms like the Advantech MIC735 and NVIDIA Helos, human-machine collaboration is truly ready to scale safely. The heavy lifting of the future won't be separated by a chain-link fence. It's going to happen right beside us.